Think like Tesla.
Geek Thoughts Micah here. Think like Tesla. So what we are doing this evening is going through the schematic, and we're going to make some changes. So, quick refresher. If you haven't seen the previous video, go check it out. We talked about a lot of the details there. But essentially, this is a driver board for 8 16-segment displays, which you can see down here. And it's going to hook up to a microprocessor or microcontroller like an Arduino. And there are 3 connections here and 8 here to drive it. So as the schematic stands right now, each of the 8 characters has its own pin up here. So our microcontroller would select these one at a time in the sequence, just rotating through these. So each character would only be lit up 1/8 of the time. So I'm thinking that's going to be kind of dim. While the character is lit up, or just before it is, using these 3 lines here, it streams in the 16 bits of data on here. Each time a piece of data, 1 bit of data is ready, it sends the clock signal, and then the latch signal moves the value from the internal registers to the storage registers, so it appears here. Through these resistor arrays, 1 resistor per LED, there'd be a lot to solder, so these are individual components. And that's about it. So the way this works right now, we need 8 different transistors to do this. And so right now it's an array. It's 16 by 8 is our configuration, and we're going to change this to be a 64 by 2. So the 64 bits would be 4 characters by 2. So half of the characters in the display could be lit up at any one time. That'll be a lot better for flicker. Also, we'll use fewer of these transistors, but each transistor will have more current running through it. So we'll have to look out for that too. All right, so let's do this. So I want you guys to feel like anyone, if you have enough technical expertise to get to this video and to watch it, you could make your own project. You could design something, you could get a printed circuit board built, have it shipped to you, you could solder the parts on, and you could have a circuit. You can do it. If I can do it, you can. So let's see what we can do here. Now the thing about KiCad, the software, is it is made especially for people who do this a lot. And if you're a person who does this infrequently, like I am, you're going to be rusty and it's going to be kind of awkward to make this work. Let's go. All right, using the selection tool, I'm just going to blow away a bunch of stuff here. Now that's trying to move it. I actually didn't want to move it. What I wanted to do was delete block. Boom. All right. So just by selecting stuff, by default, it thinks I want to move a whole bunch of stuff around, which is not necessarily the case. If you right click, delete block. Okay, that's good. The other thing is, if you swipe up and down on the trackpad here, it wildly scrolls. There's probably a setting to make that better, but I haven't found it. Okay, so with 8 of these things, it's going to make a lot more sense to lay this out across the board here. We'll have 8 going across the top here, and then the bus lines running down. So that means I need to move these guys like that. And this one I really do want to move. Now, these are specified right now as 100 ohm resistors. That might not be the right value. We'll do some math on that in a bit. So let's do copy block. Is there a duplicate option? Nope. So we'll just do copy block. Oh, there we go. Try to get these relatively evenly spaced out and lined up. Let's go over here. I can see there going to be enough room for that? Probably not. So let's do it like this. Okay. Yeah, we are definitely going to run out of room here. In their full glory, these things are, with the resistor board, are kind of wide. So what are we up to? 1, 2, 3, 4. 4. I have to do 2 layers of these guys. So moving that first one was probably not necessary. Oh well, we'll figure it out. Delete. Clear out some more room here. Copy block. Actually, I don't want this to quite connect up with these bus things here yet. Actually, I do. Yes. So our bus is still only going to be 16 characters wide, 16 bits wide. All right, just more copying. Okay, so the default settings in the Mac version are not very good. So this one here, use touchpad to pan. This is your ticket. Get this in place, and then you can nicely pinch, zoom, and also side up and down swipe to navigate around the screen. Much better. Now let's get these capacitors hooked up. Okay, so here we have a nice looking little schematic. It's not perfect, but we're going to keep going. You can kind of zoomed out here, you can just see the structure of it. There's pairs of these shift registers. Each one is hooked on this big fat bus wire with 16 connections to this 2-digit display. And then you see the digits are multiplexed. All the evens and odds are hooked together, driven through transistors. So now we're down to 1, 2, 3, 4, 5 connections to our CPU board. Cool. Okay, so what happens next is kind of just go around these icons in order here. We're going to click this one, which is going to assign all the components. So right now these are all called like disp question mark, resistors are R question mark. We're going to annotate all those. Okay. Now we can see disp 1, 2, 3, 4. We have C4, C6. We have Q1, Q2, R1, R2. Beautiful. That worked great. Okay, now we have to do footprint. Wait, first electrical rules checking. So this is going to check to make sure if anything looks not connected. And there's a whole bunch of stuff shown up here. Okay. Pin connected to some other pins, but no pin to drive it. So this probably has to do with making the bus correct. Making sure all the little details of the bus got wired up correctly. This could get boring, so let me fix that and come right back to you guys here. Okay, we had some fixes here. We'll click on the bug again and run, and nothing happens. That's good. That's what you want to have happen. No error reports. So the electrical rules checker it's kind of like running your source code through a compiler. It's just checking to see if there's any things that just don't make sense in your schematic diagram here. So the kinds of things you look for is making sure your buses are wired up correctly, making sure you don't have power connections that go to nowhere. I always forget these 74HC595s don't have power or ground pins. They're hidden. So you need to specify power flags on VCC and ground, which I've done here. That just make sure that KiCad is able to wire those up correctly. And every once in a while you'll get wires that look like they're connected, but they're actually not. And when you zoom in, you see the little square around it. It's not actually connected, so you got to fix those. So now everything's fixed. We are ready to move on to the next step. So everything we've done here, this whole schematic diagram, this is still just an idea. This is all still abstract. Next video, we're going to define footprints, actual physical layouts of these components, what they look like. I've already done so for these character displays. These resistor arrays, we have to decide if we're going to do surface mount versus through hole, and then we will get into the fun part of actually laying out the PCB. So that's going to be a blast. So stick with me. We'll have a fun time. Oh, and then I also finalized on the resistor value of 1.5K for these based on physical experimentation, which is a good thing I did because I found out that the forward voltage drop of the LEDs in these displays is actually less than what the spec says. So 1.5K with 5 volts ends up being about 2.2 milliamps through these, which is plenty bright, as you can see here. And it's even if all 64 segments were lit up at once, that would only be about 140 milliamps, which is well within the 200 milliamp range of these small signal transistors. So everything looks good as far as the schematic goes, and we are ready to move on. So stay tuned for the next video coming soon.